On week number 2, lesson number 1. A lot of work to do today, so let's get right into it and figure out what we got going on. So, our little agenda for the day: what is an algebra? We talked about it a little the other day. Real world revelations, how that works in with what we've been doing. The homework answers, the do it questions where we get a chance to review the concepts. We're going to talk multiplication and division of algebraic terms, arithmetic, and so on, trying to understand what those operations are and why they work. And then properties, algebraic and arithmetic properties. So that's our routine for the day. An algebra. What is an algebra? Well, we said the other day that an algebra is an arithmetic with variables. And what that means is that if you have learned how to do arithmetic correctly, then you can apply those skills and transfer them right over to algebra, and you understand algebra. There's such a strong link between the two. On the other hand, if you always struggled with fractions and decimals and things of an arithmetic nature, but you understand algebra fairly well, you can transfer that information into arithmetic. In educational terms, we call this assimilation and accommodation. Assimilations is the ability, sorry about the dogs barking here, they're going to go outside in a second. My wife is letting them out. Assimilation is when you take a brand new thing that you're trying to learn, but it attaches to something you already know. That makes learning it pretty simple. Accommodation is when you have to build a whole new cognitive mental structure to understand something. Unfortunately, when students try to understand an algebra, they try to build a whole new structure in their brain. And that's wrong. Well, it's not that it's wrong. You can do it, but it's a whole lot harder. It's so much easier to understand it in terms of things that you should already know from arithmetic. Similarly, less frequently, if you struggled with arithmetic, but you're now doing pretty well in algebra, that doesn't happen very often, but it can, then you can go back now and understand arithmetic so much better. Today, we're going to walk through both of them side by side and have one, hopefully, assimilate ideas in your mind for the other, however your mind might need those ideas. So, when you're actually doing arithmetic, you're actually doing algebra. So, for instance, how to add fractions with you need a same denominator because it's the same category or the same type, right? So if I have one thing called fifths plus three things called fifths, altogether I have 4/5. If I have different denominators, I can't add seconds and sevenths. That would be like adding puppy dogs and kittens. That can't be done. However, I can convert them both to 14ths. Remember the little technique we showed that will always get you a common denominator? You take this denominator from the 1/2, the 2, multiply it as 1, 2 over 2, and then take the 7 on the other fraction, 7 over 7, and that gives me 7/14 plus 6/14, which is 13/14. That idea of getting a common category and putting together things that are in a common category, and if they're not in a common category, not putting them together at all, is the same idea when we simplify an algebraic expression. So for instance, if I have 14 and these look like tomatoes to me, maybe they're supposed to be apples, but call it tomatoes. 14 of them, take away 6 of them, is 8 of those tomato apples, whatever that is. 8 lemons minus 2 lemons gives you 6 lemons. And 5, I don't know what that is, but 5 of those other fruits plus 4 of those other fruits gives me 9 of the other fruits. So altogether, I have 8 tomatoes, 6 lemons, and 9 of those other fruits. If I tried to combine them, a tomato is not the same thing as a lemon, which is not the same thing as that other fruit, so they cannot be combined. That's the same exact idea that we just used to work through the addition of fractions. If they're the same, like fifths and fifths, combine them. If they're not, then we have to find a common category in order to combine them. And once we get that common category, we're done. We can't go any further. If we can't find a common category, we can't go any further, like in this 8 tomatoes plus 6 lemons plus 9 of the other fruit. And then eventually we begin to actually take that and put it into linear equations, these ideas, which we're going to lean toward later today. The heartbeat of mathematics is logic and reasoning applied to the world that we perceive daily. In the last lesson, we focused on the eternal truth that anytime you add or subtract anything in the universe, they have to be the same kind of thing. That's a very powerful understanding. Okay, we applied that to why and how we convert money, how we're able to find perimeters, exchanging currencies, everything, even puppy dogs and laundry. Now, praxis, the praxis power performance is a function of preparation. Let's start doing some praxis prep problems. We got a few of them to do. Here is the first one. We spoke of this the other day, that the sum of any two sides of a triangle is greater than the third side. So the distance we talked about from Hackensack to Freehold, the birthplace of the great Bruce Springsteen, has got to be shorter. It must be less than the sum of the two brown sides of that triangle. We could say it in a fancy way that the triangle inequality theorem says the sum of any two sides, like for instance A and B, is going to be greater than the third side, like C. There we go. Give that a shot. Remember, an isosceles triangle has two equal sides. You do your stop and start on this. I'll go over the correct answer in a minute. Okay. Here's your triangle. The correct answer is 4, 4, and 7. How come the other ones are not correct answers? Well, 1 and 1 adds up to 2. That's not greater than 3. Remember, two sides must be greater than the third. 2 and 2 add up to 4. That's not greater than 5. 3 and 3 add up to 6. That's not greater than 6. So 4 and 4 do add up to greater than 7. 4 and 7 are greater than 4, both combinations. So therefore, choice 4 is the correct answer. It has to be isosceles, so two of the sides must be the same. And we talked about how school can disembowel, take the guts out of math. It stops the perception and demands memorization in lieu of understanding. And then we talked about how if we want to do the right thing, it's so important to understand how to do that, that you are given understanding. Now, let me be clear about given understanding. I do my best to give understanding, but sometimes it takes you alone to get your own understanding. And my old high school teacher, Mr. Braze, the great teacher I told you about, he used to tell us all the time, you got to lock yourself in a closet. Think about this stuff. And that's what you do. So I try to impart understanding as best I can. Sometimes it might not work for you, but I am trying my hardest. And then you, on the other hand, have got to take what I'm offering and run with it, work with it, digest it, chew it. Mental nutrition, put you in good mental shape. Okay, remember the measure of an inscribed angle is equal to half the intercepted arc. Find the measure of the inscribed angle here. I put a little circle there. Okay, give it a shot. Stop and start. Okay, so the angle is half the arc. Remember we said why? Because the triangle has 180 degrees in it, the circle has 360, so therefore inscribed angles have to have half the measure of the arc. And that is going to be the measure of angle ACB is half of the measure of arc AB, ACB being this angle right here. Remember when we name an angle, we start A, we go to C, and then we turn around to B. Okay, so that's the measure of the angle is half the arc. The arc is 50, so half of 50 is 25. Okay, in each diagram, find the measure of angle B. Go ahead. Okay, so remember, I might not say stop and start, but you should know when it's time to do the question, you should stop the video. In this case, angle B is half of 120, that's 60. And in the next case, it's half of angle B, which is going to be 54. Okay? All right, let's try the next one here. Give it a shot, see how you are. So remember we talked about the distance formula, how it is the Pythagorean theorem, nothing more, nothing less. So in this problem over here, with the green segment, to find the vertical change, it would be 6 minus 3, and to find the horizontal change, it would be 7 minus 1. That's where the numbers come into in the formula right there. And that's how we set it all up. Okay? Now apply that to the distance between these 2 points. Okay, so you did your stop and start. Let's see what we get. We get a vertical distance here. We get a horizontal distance here. If I count this, 1, 2, 3, that distance 3. The other one is 1, 2, 3, 5. Now you could, of course, do the 2 because the formula says x from the first point, or x from the second point minus x from the first, which is 1 minus negative 4. That's where we get 5. Squared, we'll do that in a minute, and then 2 minus negative 1, which is 3. That's where those distances come from. So 3 squared plus 5 squared, because those are the sides of the right triangle, the legs, I should say, is going to equal the distance squared, which is the hypotenuse. So this is an application of either a squared plus b squared is c squared, or leg squared plus leg squared is hypotenuse squared. 9 plus 25 is equal to d squared. D squared is 34. And that makes d equal to the square root of 34. And we'll leave the answer like that for now. We won't convert it to a decimal or do anymore. Okay, and here's all of that work shown for you. And in this case, they do convert it to a decimal to 5.83. Okay, all right. Here's your homework answers. I'm going to pause. You're going to run through there. I'll highlight a couple of things in a minute after you've had time to check your answers. You can do stop and start. Okay, so remember, explain the humor in the joke. There are 10 kinds of people in the world, because in binary, the number 10 is really 2, right? 2 to the 0, 2 to the 1. There's no 2 to the zeros, which is 1. And there is 1, 2 to the first power, which is 2. So 10 in binary is 2 in the decimal system, or base 10. Number 2, convert to base 10. You notice we start with 2 to the 0, 2 to the 1, 2 to the 2, 3 to the first, 16 to the second. Anything to the 0 is 1, so I have 1. C is actually the number, A is 10, B is 11, C is 12. So that's 12 times 16. And then there are 3 256s, because 16 squared is 256. Add those all up, multiply them out, you get 961. Find the sum in the same base. So in this case, we are finding the sum in this particular base, 357 plus 453. 7 and 3, that adds up to 10. But in base 8, that's really a 2. Bring it up. 6, 10. Well, we get 4122 out of it. In letter B, we add these up. We get 10000 out of it. Find a difference in the same base. I just found out. I got stumbled a minute ago. I just found out that my external hard drive got separated, and I'm hoping it didn't screw things up on us. Here's your subtraction, 251 in base 16. And then in base 5, we've got so that would be 5, which would be 6 minus 4. I miswrote here. This should be 1022, not 1025, 1022. There's the rest of let me go back here. Here's the rest of the homework answers. Take a look. Stop and start, of course. Okay. Everything's pretty straightforward on this. So you should be, we've gone over questions like this now for a couple of days. If there's any questions about them, reach out to a classmate, reach out to myself, or rewatch those sections of the video. Today's do it. Stop and start time. Here you go. Go through those. We'll go over the correct answers as soon as you're done. Okay, 8 plus 11 is 19 in clock math. That's better known as 7. 8 minus 10, if you started at 8 and go back, that actually equals 10. 7 times 3 is 21. The remainder upon division by 12 is 9. Here's your factoring. €1 is $1.09. How much is $5 plus 11.5 euros? You immediately notice that you cannot add dollars and euros, so we have to convert one to the other. In this case, we're going to convert euros to dollars. 11.5 euros is 11.5 times $1.09. That's $12.54. And then the $5 you started with, added up $17.54. Explain what adding fractions and lining up decimals has in common with adding up puppies and kittens. When you add fractions, you need to get a least common denominator. When you line up decimals, you are grouping the same type of category together. And when you add puppies with puppies, that works because it's the same category. And then we have kittens with kittens. That's also the same category. And then if you don't line up the decimals, then it would be different categories, which would be like puppies and kittens, and that wouldn't work. Simplify by combining like terms. 3x squareds and a negative x squareds are 2x squareds. 8x's and negative 9x's is a negative x. And negative 4 and positive 9 is positive 5. Okay, the opposite pair sides of rectangle measure 27 feet and 8 yards. Danger, danger, danger. You can't get feet and yards together. You got to do a conversion here. What's the perimeter? I will convert the yards to feet. Remember, every yard is 3 feet. Oh, I'm sorry. I'm going to convert to yards. 27 feet divided by 3 is 9 yards, right? Because every 3 feet is a yard, so I get 9 yards. And then I have 4 sides, 8 yards and 8 yards, 9 yards and 9 yards. Altogether, that's 34 yards. Now, new stuff for today. Let's talk about it. Multiplication and division. So the first question is, do we have to have the same category to multiply and divide? Well, let's look back at the last question about the rectangle and the opposite sides. Couldn't I have done this? Couldn't I have done 2 times 7 yards plus 2 times 9 yards? Is 14 yards and 18 yards, I get 34 yards? Let's take a look back at that. See how we had 2 of 8 yards and 2 of 9 yards? So I didn't need common categories to multiply or divide, in the sense that 2 times 7 was 14, and you just kept the category of yards. It didn't matter, okay? You do 2 times 9 yards is 18 yards. So you can multiply a number by yards. So you don't need a common category to multiply or divide, okay? And you also don't need to line up the decimals when you're doing decimals. And you don't need to get a common denominator when you're doing fractions, because you don't need a common category. Algebraic properties. Let's start talking about that. So let me just go back, and I'm a little off my game today. Let's summarize what we have going on there with multiplication and division. They do not need the same category. Because they do not need the same category, you can just multiply and divide pretty much at will. And you don't need to line up decimals because you don't need the same category. And you do not need a common denominator when multiplying or dividing. Now, this leads us to our next topic of the day, which is the algebraic properties. And a lot of teachers ask kids to memorize algebraic properties. I remember being a student in 9th grade and in 8th grade. I take the Regents exam in algebra. I scored well. I got in the 90s, but I didn't get like near 100. Yet I took trigonometry and advanced algebra, and I get near 100. I take calculus, and I got a 4 out of 5 on my calculus AP exam. How come I did so well on those and not so well on these? Well, because I was bored with math when I was taking 9th grade math. I was just taught that these properties, they kind of had these weird names, and I never understood where the names come from. If you understand where the names come from, then the properties really are pretty simple. And let's talk about it. First property is the commutative property, right here. And the commutative property, the root word for commutative is the word commute. And to commute means to switch. In fact, you see this used frequently on the weather in the wintertime when we're worried about a storm, and you'll hear the forecaster come on and go, and now for tomorrow's morning commute. What that means is, like, you drive from, say, Hackensack to Manhattan in the morning, And then in the afternoon, you go from Manhattan back to Hackensack. So you're switching the direction. The other sense that you hear the word commute is when a governor of a state or the president of the country commutes a prisoner's sentence. They have the legal right to do that. What does commute mean? It means to switch the prison sentence. Okay. So here are some examples. The commutative property, the first one is of addition, because 5 plus 2 is 2 plus 5. See how we're switching the order there? Okay. So that's an example of the commutative property of addition, because addition is going on. And then in example 2, it's the commutative property of multiplication. Again, you can see the 3 and the 7 are switching, but you're multiplying. I distinctly remember, when you're a kid, there are certain things you remember that you're like, why do I remember this? I remember having this teacher in 7th grade, Mr. Muller, and he gave us a quiz on these algebraic properties. And when I answered this one question about the commutative property or the associative property, it was one or the other, I remember being able to know whether it was commutative or associative. But then they had the choices were commutative of addition, commutative of multiplication, associative of addition, associative of multiplication. And I remember getting stuck on whether it was of addition or multiplication. And I just kind of guessed, and I guessed wrong. It's really easy, guys. If you're adding, it's the commutative property of addition. If you're multiplying, it's the commutative property of multiplication. So rather than go crazy trying to memorize and get out flashcards for what the commutative property of addition or of multiplication looks like, just remember to commute means to switch. So anytime that you look at an example of a math term, whether it be letters for algebra or numbers for arithmetic, and the order is being switched, you know it's commutative, because to commute means to switch. Remember, Hackensack to Manhattan, Manhattan to Hackensack. But whether it's of addition or multiplication, just look in the problem. If they're using addition, it's commutative property of addition. If they're using multiplication, it's of multiplication. Now, what about the associative property? Well, the root word of associative is associate, and it means to be grouped with. Growing up, did you ever get in trouble when you hung out with a particular kid or kids? I know growing up I did. I know my sons did. And I said this, my parents said it to me, and your parents probably said it to you. You will not associate with whatever the kid's name is. So in the associative property, it's all about who you're being grouped with, who you're hanging out with. So let's look at the first example. This example is of the commutative property, or the associative property, the associative property of addition. Look at the 4 in the middle. Parentheses are known as grouping symbols. First, the 4 is being grouped with the 5. And then on the other side of the equal sign, the 4 is being grouped with the 3. So we're changing, and this is critical for the associative property. We're changing which term or which number the middle term is being grouped with. And it's equal either way. Watch. 5 plus 4 is 9, plus 3 is 12. 4 plus 3 is 7. Order of operations here. 5 plus 7 is 12. So 12 equals 12 either way. When it doesn't matter which way the 4 is grouped, that's called the associative property. Now, not everything is associative, just like not everything is commutative. In fact, the only things that are addition and multiplication. Take a look at example 2. Notice in the first part, the 8 is being grouped with or is associating with the 9 first, 7 second. And in the second side here, the 8's being grouped with or associated with the 7 first, and then the 9 second. Okay? Oh, God. So those are examples of the associative property of addition and the associative property of multiplication. So far, what we're doing is, rather than trying to build a whole new structure in our brain, accommodation, we're going to try to assimilate this knowledge into what we already know. For example, the commutative property, the word commute means to switch. Look, if I see things being switched, like the 5 and 2, 2 and 5, 3 and 7, 7 and 3, that tells me, oh man, that's the commutative property. I have to go with that. Then the associative property says, nah, associate means to be grouped with. So look, we're changing who the 4 is grouping with. We're changing who the 8 is grouping with. So that's an example of the associative property. The last property that we emphasize is the distributive property. Now, distributive is linked to the word distribute, and to distribute means to give out. Whenever I think of distributing or giving out, I think of two things. I think of Christmas time, and Christmas presents are distributed or given out to family members and so on. But the other one I think of, sadly, is the Great Depression and how we used to have these things called soup kitchens. And soup kitchens are places where people without any food and money to afford food would go, and they would distribute like a piece of bread to them and then some soup to them. Maybe they got lucky and had a little bit more that they could distribute to them. But it was a place to go where the people could get something to eat. So when I see something being distributed, like, for instance, 5 times 3x plus 1, 5 times 3x is 15x, 5 times 1 is 5. So the 5 is being distributed or multiplied by everything in the package. The last example, 2 times 4n is 8n, and 2 times negative 8 is negative 16. Now, sometimes in their minds, students say to themselves, look, if I see parentheses, it's associative. If I see no parentheses, it's commutative. Not necessarily, as you will find out. And for distributive, there are parentheses. But you'll notice that once you distribute the 5, only one side has parentheses. All right. Here's a chance for you to do some matching. We've got properties listed on the left. We've got the names of properties on the right. Go ahead, match them up. Little stop and start time. Okay, so the first one is an example of the commutative property of addition. Notice we're switching order. 8 plus 3, 3 plus 8, they both equal 11. Next one is an example of the distributive property, because the 7's being multiplied by the 4. That's what 7 parentheses 4 means. No symbol in between means multiply. And the 7's being multiplied by the 5. I don't know why I put an 8 there. That's supposed to be a 5. That's a really strange looking 5. Okay? Next up, commutative property of multiplication. Again, the order changes. 9, 3, 3, 9. But this time we're multiplying. Next up is an example of the associative property of addition. Notice the A is changing who it's being grouped with. In the beginning, it's grouped with the C. At the end, it's grouped with the A. Okay? So that's an example of the associative property of addition because everything is being added. Associative property of multiplication is here because no symbol between things means multiplying, as I just said. First, the A is being multiplied by the B, and in the second case, the A is being multiplied by the 3, and they're equal either way. That is the associative property of multiplication. So that leaves one left. 4 plus 9 plus 7 equals 7 plus 4 plus 9. What property do you think that is? Well, a lot of people will think it's an example of the associative property of addition, and they would be wrong. The reason is this. If you look carefully in the parentheses, on the left-hand side here, the 9 is being grouped with the 4. But on the right-hand side, the 9 is still being grouped with the 4. What's changing is the addition of 7. On the left side, it's the parentheses plus 7, and on the right side, it's 7 plus the parentheses. So you're actually changing the order, you're switching the order, and that is an example of the commutative property of addition. So here's an example of a food kitchen during the Great Depression with soup being distributed. Remember, to distribute means to give out. So you're probably very used to examples like this first one here of 5 times x plus 3. 5 times x is 5x. 5 times 3 is 15. The answer is 5x plus 15. Once again, follow my cursor here. 5 times x, 5x. 5 times 3, 15. Try number 2 very quickly. Okay, so 7 times 3x is 21x, and 7 times negative 5 is negative 35. All right, try the next 2. Little stop and start moment. So the answer to the first one, 4 times 7x is 28x, 4 times 5y is 20y, and 4 times negative 3 is negative 12. Number 4, I throw a little wrinkle in there with a negative in front, and we're going to talk about multiplying by negatives in a future lesson. Hopefully for now you either know it off the top of your head or you put it in your calculator. Negative 3 times 3y is negative 9y. Or negative 3x, sorry, is negative 9x. And negative 3 times negative y is positive 3y. A hint as to what the future will tell you is every time you multiply by a negative, you have to change the sign. Now, this is an example of where I think algebra, because remember, algebra and arithmetic are the same thing. It's just the difference is that with an arithmetic, we're working with numbers, and with an algebra, we're working with variables. This is a case where I think most students would understand the 4 examples that we just did pretty easily, pretty straightforward. But then they look at number 5, and they don't understand that using the distributive property, you can do these in your head really quickly. In fact, as quick or quicker than you can on a calculator. This is an example of where, understanding the algebra goes back to help the arithmetic. So 3 times 31, I want you to think of 31 as 30 plus 1. And 5 times 47, think of it as 5 times 40 plus 7. So with that, you can do that arithmetic in your head using the distributive property. Go ahead, try the first one, number 5. Okay, so 3 times 30 is going to get you 90. And 3 times 30 is 90, and 3 times 1 is 3, and 90 plus 3 is 93. So that's an example of using the distributive property to multiply bigger numbers in your head. And whenever I've had the opportunity to work with younger elementary school students who are just learning multiplication or even division, I always teach the distributive property in your head so that they can learn how to do that, and it really sets them up for future success in algebra. Okay, try number 6. Okay, so 5 times 40 is 200. 5 times 7 is 35. So 200 plus 35 is 235. Again, very easy to do in your head and not write anything down. So here's some more practice distributing. Try these 6 examples. Try all 6, and then I will show you the answers. Remember, do stop and start. Okay, so for the first one, 9 times x is 9x. 9 times negative 3 is negative 27. For the second one, 4 times 3x is 12x. 4 times negative 2 is negative 8. 7 times 7x is 49x. 7 times 5y is 35y. 7 times negative 3 is negative 21. Negative 8 times 3x is negative 24x. Negative 8 times negative y is plus 8y. Okay. You can also do arithmetic in your head that way, right? 3 times 34. Oh, I wrote 30 plus 1. That's supposed to be 30 plus 4. That's going to be 3 times 34. 3 times 30 is 90. 3 times 4 is 12. 90 and 12 make 102. So you can see the 4 here. Just didn't write it to start with. And then 5 times 37. This is 47, sorry. 5 times... Oh, see, this I should have changed this 40. Should be 5 times 30, which it says here, which is 150. And 5 times 7 is 35. And 150 plus 35 is 185. If you were to type it in a calculator, you would get 185. But I can do these lightning fast in my head, and so can you. Okay, so don't give up on this. This is a good example of how understanding a property can help you be better at arithmetic. But did you know that we're distributing when we do typical multiplication from our youth, right? Because we're doing the 2 times the 6, then the 2 times the 5, then the 2 times the 7, or the 3 times the 2, the 3 times the 2, the 4 then times the 2, and the 4 times the 2. So we're doing a sort of double distribute when we are doing our multiplication in arithmetic. Now, what if you have 2 people and 2 foods at a like a food bank? How would you distribute if there were 2 different containers of food? Well, you would have to give what's in the first container, the 2x, to both of the people, and then you would need to give the 7, what's in the second container, if you will, to both the people. Maybe the 2x is hot soup, and maybe the 7 is nice bread. If I do that, 2x times x is 2x squared. 2x times negative 3 is negative 6x. You'll notice I wrote that in red to show you that when I do this, now some teachers years ago, they used to call this FOIL, first, outers, inners, last. I hate that name because it makes math sound gimmicky, just another something to remember. This is nothing more than double distribute. I ignore the 7 and I distribute the 2x. That's what I just did. Now I ignore the 2x and I distribute the 7. 7 times x is 7x. 7 times negative 3 is negative 21. That gives me 2x squared plus x minus 21. So let's see you try to double distribute the first question on the upper left. Okay. Now, distributing the x times x is x squared, x times 5 is 5x. Now I ignore the x and just distribute the negative 8. Negative 8 times x is negative 8x. Negative 8 times 5 is negative 40. The thing about double distributing is these middle terms, you will always be able to combine them because they'll be the like type of thing. 5x's and negative 8x's are negative 3x's. So notice something here. It's very subtle, but it's an application of what we learned yesterday about addition. When terms are the same kind of thing, you can add them or combine them. And that's what we have here in the middle. The 5x and the negative 8x make negative 3x. But when the terms are different, you can't combine them with addition. So my final answer is x squared minus 3x minus 40. I can't go any further than that. All right, let's see you try the next one. Go ahead. Stop and start, of course. Okay, ignoring the 9, distributing just the x. X times x is x squared. X times 11 is 11x. 9 times x is 9x. And 9 times 11 is 99. The middle terms are combinable. 11x's and 9x's make 20x's. I cannot combine x squareds with x's or numbers. Those are all different types of things, like puppy dogs, kittens, and ferrets are all different types of things. Final answer, x squared plus 20x plus 99. Okay, let's see you try the next two. 3x minus 7 times x minus 4 and 4x minus 9 times 2x plus 5. Give it a shot. You have done stop and start, I assume. 3x times x, 3x squared. 3x times negative 4, negative 12x. Ignoring that 3x now. Negative 7 times x, negative 7x. Negative 7 times negative 4 plus 28. Always combinable in the middle. Negative 12x and negative 7x make negative 19x. So the final answer is 3x squared minus 19x plus 28. Next one. 4x times 2x is 8x squared. 4x times 5 is 20x. Negative 9 times 2x is negative 18x. Negative 9 times 5 is negative 45. So that's 8x squared plus 20x and negative 18x is 2x minus 45. Okay? Double distribute can also be applied to numbers to multiply a two-digit number by a two-digit number in our heads, and it could be even faster. And you can also triple distribute. In this case, you're going to distribute the 2x squared to both of the terms, then the negative 5x to both of the terms in the second binomial, or the end of binomial, and then the 9 to both terms, and then combine what is left. So go ahead, try to triple distribute. Let's see if you can get this right. Same idea as double distribute. Okay, so distributing the 2x squared times x is 2x to the third. 2x squared times negative 3 is negative 6x squared. Negative 5x times x is negative 5x squared. Negative 5x times negative 3 is 15x. 9 times x is 9x. 9 times negative 3 is negative 27. Combinables here with the x squareds and then also with the x's. Now I can't combine x squareds with x's, but I can do my x squareds together and then my x's together. That gives me a final expression of 2x to the third minus 11, because negative 6 and negative 5 is negative 11, x squareds. And then 24x, because 15x and 9x make 24x, minus 27. All done. Now, you can do the double distribute and so on in your head, or you can do what I was taught was Russian multiplication or the box method for how to do how to compute one of these problems. So here we have it, x plus 7 times x minus 5. And what I do is I set up like a Punnett square box, right, like this. And on the top I write x plus 7, and then on the right I write x minus 5. And then to complete each box, I just multiply what's there. X times x is x squared. And next up we have 7 times x is 7x. It is positive. You might want to write that in the box. I just put a negative in there when I need to. I don't put positives in. Negative 5 times x is negative 5x. And negative 5 times 7 is negative 35. Now what you're going to do is you're going to add on the diagonal. So it's x squared, and then 7x and negative 5x make plus 2x, and then negative 35. There's that on the diagonal that you're going to add on. X squared plus 2x minus 35. The 2x comes from adding on the diagonal in the green. 7x's and negative 5x's make 2x's. Okay, you try the next one. Okay, completing my box. And for some people who like a lot of structure and how they do things, these boxes work great. X times x is x squared. Then we have 3 times x is 3x's. X times negative 8 is negative 8x. And 3 times negative 8 is negative 24. Remember to add on that diagonal. I get x squared minus 5x minus 24. Okay, next up, 3x minus 7 times x minus 5. We have them written in place. Go ahead, do it, and we'll check your answer in a moment. 3x times x, 3x squared. Negative 7 times x, negative 7x. 3x times negative 5, negative 15x. Negative 7 times negative 5, positive 35. Add on the middle, and 7x, negative 7x's and negative 15x's make negative 22x's. So the final answer is 3x squared minus 22x plus 35. The happy recap. An algebra is an arithmetic with variables. You have, without knowledge, been doing algebra since you first started doing arithmetic. It's the same stuff, but with variables. Distribute means to give out. Associative means being grouped with. Commutative means switching. The names of these properties are logical based on the definitions of the words used in the English language. So please don't go crazy trying to memorize the properties. Instead, be able to recognize them based on what's going on in the problem. Are the terms being switched? Are you giving out something to both of the terms? Are you changing who the middle term is being grouped with? And that in turn directs your property. Then just look and see if it's of addition or multiplication. You've been using the distributive property for many years, and it can actually make arithmetic and algebra much quicker and easier. All right, so that's our happy recap for what we had during class today. Now, let's talk about this great video, Be Phenomenal. 30 million views. That's my dog snoring. Well, you know, for some reason, this won't start. But we're going to come back to that video in a minute. Important ways to succeed in class. Do all your homework when due. It's kind of like extra credit. We've been over that. How you go about your business is critical, right? If you get something wrong, find out why and how you got it wrong so you don't repeat the error. Otherwise, you are drilling into your head how to do something wrong. Pay attention to due dates on Moodle. Some kids miss due dates. Due dates being missed definitely hurts your grade. Work together on projects. Take pride in your work. And then every day is a chance to realize your dream or not. You know, I used to tell the kids in the class, when I taught in the classroom, physical classroom, that like if on the other side of the classroom door was success and in the future that they wanted, every day was a chance to walk a little closer to that door until you could actually open it. And if you just didn't do your work that day, it's not necessarily that, you know, you're a bad person, but you don't get any closer to that door. And if everybody else in the room is doing their work and they are getting closer to the door, that can create a giant problem for you. Okay, so now what I'm going to do is go to that Be Phenomenal video because I can't believe it wasn't done there. YouTube. Be Phenomenal. Here we go. I can't believe this is not uploading. I have no idea why this isn't uploading. It always uploads. So, well, I guess what you'll have to do is add a little tiny piece to your homework and go to YouTube, look up Be Phenomenal, and get the one with 30 million views. It's really worth watching. I can't believe that for some reason, oh, I know what might be going on. Sometimes in the background, nope. Oh, well, sorry about this. I can't believe it's not working at this particular moment. So let me refresh this page here a little bit here. Let me just check and see if that works. Shows I'm still connected. Something very strange going on with my computer at this point in time. So you look it up on your own. The Be Phenomenal video, 30 million views. It's in YouTube. Have a super fantastic day. Take care.